Hi again, eighth graders. We're going to continue this lesson on Jack and Jill and continue building into linear relationships. So, activity 2.3, we're going to look at the equation of a line that's not through the origin. So this says Jack and Jill's Aunt Mary lives 10 yards from their home closer to the bus stop. After spending Monday night at Aunt Mary's house, they leave for the bus stop from there Tuesday morning. They walk at the same rate from either house, 4 yards every 3 seconds. The graph shows the line y equals 4/3 x, which represents the relationship between the time Jack and Jill walk and their distance from their house. We're going to compare these two situations. So, how do the slopes compare? So, again, we're comparing when they walk from their house to when they walk from their Aunt Mary's house. So, it did tell us they are traveling at the same rate, which is what the slope represents. So, the slopes are actually going to be the same. The slopes are still going to be the same because they're walking at the same rate. So, the slope of the two situations are the same because they are walking at the same rate. How do the starting points compare? So this line represents when they walk from home because they are 0 yards from their house. They're starting at their house. When they're at their Aunt Mary's house, it tells us that that's 10 yards away from their house. So that means they're starting up here at 10. So for the starting points, when they start from their house, they start at 0 yards on the graph. When they start at their Aunt Mary's house, they start at 10 yards on the graph. So it's kind of like translating the graph vertically. Now let's actually graph a line to represent the walk from Aunt Mary's house. So on a piece of patty paper, trace the line y equals 4/3 x. So let's trace it. Got my patty paper here, and I'm going to trace the line y equals 4/3 x. I'm going to use a straight edge because I want to make this nice and straight. Here we go. So there's the line y equals 4/3 x. And it also says be sure to include the triangle representing the unit rate on my trace. So that would be right down here. They have it kind of highlighted in your book in like a purple color. There's my unit rate, the triangle for unit rate. Now it says translate this line to represent their walk from Aunt Mary's house and then transfer this line onto the graph. So before I do that translation, I'm just going to flip my patty paper over and I'm going to work on, I'm just going to copy it to the back so that I can transfer it over. So just kind of tracing this on the back so it will transfer over. Okay. So now it said to just translate this so it lines up for the walk from Aunt Mary's house, which we said is going to be at 10. So we're just translating this up to 10. Right there, we're going to line up our unit rate here. And then I'm just going to go over this line to hopefully transfer it over to my graph, to my coordinate plane. So please be doing this with me as you're watching. And there we go. there's the line that represents their walk from Aunt Mary's house. So let's look at this. Does your new line represent a proportional or a non-proportional line? And explain how we know. So again, two things to look for a proportional relationship. It has to be a line and it has to go through the origin. That definitely does not go through the origin. So the new line does not represent a proportional relationship because it does not pass through the origin. All right, now we're going to look at how this affects the actual coordinates. So how does this translation affect the coordinates of the line? Complete the table to show how the translation affects the coordinates of your new line. Well, first of all, we know the starting point is not at 0. It's at 10. And we also know what a translation does to the coordinates of a graph. Translation just adds the same amount. So if we're adding 10 here, we just went up 10 units. That means we're adding 10 for all of these. So I'm going to write these in fairly quickly just by adding 10 to the original. So 4/3 was the y coordinate for when t equaled 1. I'm going to add 10 to that. So that'd be 10 and 4/3, which is really 11 and 1/3. When t equaled 3, originally the y coordinate was 4, so when I add 10 to that, I get 14. When t equaled 6, y equaled 8, or the distance equaled 8, so add 10 to that, that would be 18. 7.5 for t means that this distance increases by 10, so 10 plus 10 would be 20. And same thing for the last one. The original distance was 12, add 10 to that, now it's 22. So translation just adds the same amount to every coordinate, to every y coordinate. This was a vertical translation, so that affects only the y coordinates. So how does this translation affect the unit rate? If we look back at our graph, the unit rate is also the slope of this line, the steepness of it. You should notice that the steepness did not change. So this translation did not affect the unit rate. It did not change the unit rate. The unit rate stays the same after this translation. Write an equation to represent the translated line. Let y2 represent the distance from Jack and Jill's house, and let x represent their time spent walking. Explain how this line is the same and different from the line. So this is the original one. This is the equation for the original one, y1. So this is y1, this is y2. We have an equation for this. Y1 equals 4/3 x. All we did was translate that line. We just slid that line up by 10. So based on what we know about translations, all that happens is we add 10 to this. So y1 equals 4/3 x. That means y2 is going to equal 4/3 x plus 10. So the only difference here is that the y2 line, when they start from Aunt Mary's house, adds 10. They have the same slope, but different starting points. Which leads us to a general equation, y equals mx plus b, to relate independent, dependent variables and the slope in a linear relationship. How does this equation change when the line is translated vertically by b units? So in the very last lesson, we saw an equation that looked like this at the very end, y equals mx, where m is the slope. If that's translated vertically by a certain number of units, they're using the variable b, All we do is take this equation and add whatever that is to it. Exactly what we did up here. Took the original equation that was through the origin. Since we shifted it up and translated it vertically 10 units, we just add 10 to the end of that. So for this equation, it would be y equals mx plus whatever that variable b is for the vertical translation, however many units that is. So now we see a linear relationship is represented by this equation, y equals mx plus b. Linear relationship that is not going through the origin and is not proportional is represented by this equation. Have a great day, everyone.